My name is Yusuf, and I'm here to explain briefly the bubble sort algorithm. So let me annotate real quick. We're gonna start out with an array, right? And we're gonna give this array 7 components. One, two, three, four, 5. I believe that is 7. Okay. So we are gonna put values into this array, say 64, 34, 25, 12, 22, 11, and 90. Okay. So now we're gonna go one by one. So the way this algorithm works, and it's quite inefficient, is it starts with the first element and it looks and compares which of the two is larger. Now, anyone could tell, even a kindergartner, that 64 is larger than 34. So what do? 34 gets moved to the first, uh, over here, to the first block, and then 64 gets moved to the next one. So what happens is 64 gets moved to the next one, 34 gets moved. So this is now, second, so now 34 is here, and 64 is here. So now it happens again, rinse and repeat. So 64 and 25, which is larger? 25 is not as large as 64, so 25 gets moved to the previous one, and 64 gets moved to the next. So we have over here, uh, 64, or sorry, 25 gets moved to the first one, and 64 gets moved to the next one. Now we compare again. 64 and 12, which is larger? Of course, 12 is not as big, so again we move it. 12 gets moved here, 64 gets moved here. We compare again. 64 and 22, or 20, 22 is smaller, of course, so again we move it. 22 gets placed here, and 64 gets placed here. And then we keep going till the end, right? 64 and 11, which is larger? 64 is larger, so 64 gets placed here, and then 11 gets placed here. Now, 64 and 90, 90 obviously is larger, so we're going to keep it the way it is. Now we have the array in a way that it's like this. I'm going to type it out this time. So now the order of the array is 34, 25, 12, 22, 11, 64, and 90. Now, I'm going to try to draw some a barrier just to make it look, you know, like the previous one. Okay, that is our array now. Is this correct as a final answer? No. So what do? We have to loop again. This tells us that we need to do a for loop and within a for loop, so a nested loop. So we keep doing it again. 34 and 25, which is larger? 34 is larger. So then, of course, 34, I'll try to draw it out. 34 is moved here because it's larger, and 25 is moved here. It is shorter, smaller. Again, 34 and 12, which is larger? 34. 12 gets moved back here, 34 gets moved up here. Now we keep going and going and going until we have a final answer that is correct. Now, let's explain the code real quick, because now that we understand the conceptual understanding, or the conceptual explanation, we will have it coded out. So the way we have it is we set the scene. We're going to have an array. In our case, it was 7. The value of the length is 7. And then we put it in a for loop, right? So for I in range n, this is the outer loop, right? This loop runs from the start of the list until the end. And each iteration of this loop represents a complete pass through the list. Now then the inner loop, for j in range of 0 to n minus I minus 1, this is where the magic happens, all right? This is where the loop compares each pair of adjacent items. So it goes up to n minus 1, or n minus I minus 1, because every time you have a pass, the largest unsorted item bubbles up to the correct position at the end. So then we ignore the last sorted items, right? Minus 1, minus I. So, and then over here we can see that it gets swapped, right? If the value of the cell is larger than the value of the next cell, then the value of this cell is going to get switched with the next cell, and then the next cell is going to get switched with the current cell. So we saw that in the drawing. And then if you have an example here, this is the same array that I showed you earlier, and we pass that through the function. What do we get? At the end of the day, we get the correctly sorted array in order. So what is the worst case running time? Well, it's n minus 1 times what? Or plus n minus 2. And we're going to keep going, right? I can keep going, but if we just keep adding, it will go all the way down to, of course, plus 2, and then plus 1. Now, this is the same thing as n minus 1 over 2, which is the same thing as this. Now, of course, our time complexity tells us that this is a very inefficient algorithm, and the more data that you have, the more time that it takes, and the more inefficient that it is. So it is optimal to use other sorting methods when you have large data. And this is just a cool example, a cool sorting algorithm, but it's not recommended to use, especially on large data.